G class for on-load tap changers, maintenance, and retrofitting. I'm Brian Twyble. I'm the marketing manager for the Tress Field Service Group for travel site repairs and retrofits. I'm with ABB. I'm in the Nashville, Tennessee office. As part of the Field Service Group, one of our statements is providing a new level of intelligence-based service that improves the performance, ability, and efficiency of our customers' transformer database with the stressing of the intelligence base. And we'll talk about that as we get into the tap changer retrofit. Part of the resources when you're doing maintenance and retrofitting, we have a fleet of oil processing rigs, onboard generators, dry air, oil handling equipment, and test equipment as well. Part of the maintenance and retrofitting cycle, you get into the project management, which is really after the quotation phase is the starting kickoff point for us. You have scope definition, you have schedules, material procurement, logistics, manpower, personnel, equipment, cost control, reporting, and also the liaison to wider ABB capabilities in the event you get into something else besides just the LTC issue. Part of the transformer base, talking about load tap changers, they have statistics that 16% of load tap changers are basically the transformer failures in today's marketplace. Part of that, LTCs, is the maintenance cycle of it. A lot of LTCs today, whether they're new or old, all of them require maintenance at some stage along the way, basically because you have windings, cables, bus bars, contacts, resistors, reactors, bushings, all of them have some capability connection to the LTC itself. Talk about contact wear. One of the main concerns for LTC is the contact wear. Basically, that's your current carrying component inside the LTC. When you have contact wear, basically it's when the unit's switching from one tap to another. You have electrical contacts, you have arcing contacts. Most of them are copper, some of them are silver inlaid material today to help them extend the life of the contacts. But when those contacts are sliding together, they're making friction, so you're going to have those issues as well. Part of what happens is you have the oxygen in the oil, which basically aids in the formation of what we call copper oxides. And the copper oxides basically form a film creation on the contact surfaces of the LTC. And that's how you get into your coking issues, which your contact, the film starts building up, your contacts are not making 100% as they're sliding back over, so therefore you get into what we call coking effect, which is just a black carbon buildup on the contact surface itself. It's a normal thing that happens in tap changers. It happens in almost all tap changers. And what they're trying to do is use resistive vacuum-type tap changers to limit that arcing that's going on those contacts today. But a lot of your older transformers had what they called preventative autos, so you have the arcing going on in the LTC. You get the contact wear, you get the coking as just a natural effect of an LTC. Another component in there is insulation materials. You have paper, terminal boards, press board barriers. Linkages are made out of the insulation material as well. Basically, you're concerned with these breaking or cracking over time. Age has a lot to do with it. Previously, they used insulation boards. Today, they're using more epoxy or fiberglass type boards. So you have less breakage on them under vacuum. Most tap changers today will withstand full vacuum. A lot of your units 30, 40 years old will not withstand full vacuum. Some are partial vacuum, some are zero vacuum. It just depends on the type of tap changer that you have. Also, you have mechanical parts. You have the contact assemblies, the drive mechanisms, the bevel gears inside, cam switches, things of that nature that are all inside, that are the mechanical side of it. May be inside the tap changer, it may be inside your motor drive cabinet. These components, whether they're the switches, the motor drives, are all different variations. We're talking about the mechanical parts of it. Basically, that you get wear, excessive wear on your component parts, so you've got to identify those as well when you're doing your inspection. Another big item is the oil inside. You have carbonization that's going on, as I talked about, the coking, contact wear. You also have oxidation, which is just a natural part of the oil. You have oxygen in there, you have moisture in there. Also, you have moisture contamination and then metal arcing byproducts, which is the two what I call contact wear and the arcing, is putting that copper inside the oil. So you have all those components inside the oil that you're trying to filter out. The best thing to do, today we have filters that we place on LTCs, is to put the filtering system on and run it continuously. You can run it in cycles as well, whether it's a day or 2 days. It just depends on how dirty the oil is getting and what type of tap changer or what the recommendation would be. But we retrofit those on LTCs today as well. So you're basically cleaning your oil constantly, keeping it clean, and what that does in return is it lengthens your maintenance cycle because you have cleaner oil, therefore you don't have to go in and perform your maintenance quite as often. It also helps to give you some key signature gases if you're doing some DGA. With that filtering, it takes out the byproducts. The tanks, you also have tap changers that are in-tank tap changers or out-of-tank type tap changers. What you have to concern yourself with there is the gasketing material. You have doors on some of these tap changers. You've got gaskets, what we call the nitrile, I guess is what they are, behind the gasket doors. Typically you'll get about 30, 40 years of length or service out of those gaskets. But if you open up the door, you want to replace the gasket every single time. You don't want to open it up and put the door, close it back up, because you have tolerances on how tight you tighten the hardware, and without replacing that gasket, you'll probably end up with a leak after you do that. So you want to make sure you do that. Also, there's some weld seams and paint finish. You should verify those as well. Basically, the welding is typically like you would on any tank. You're just verifying that there's no leaks or anything on the tank when you're doing your maintenance cycle. Some other general maintenance, you're going to have oil handling. All these tap changers have oil in them, whether it's an in-tank tap changer or a tap changer on the end of a transformer. They're going to have oil of some form in them. Also, the visual inspection. When you're doing the visual inspection, you want to go inside. We'll talk about doing the tank inspection inside the unit, and we'll also talk about pulling the switch, the diverter switch, to look at the unit outside the tank as well. Also, during the maintenance, you're doing sequencing checks, alignment checks. This is all part of your timing sequence. Timing is very critical on a tap changer. You want to make sure that your tap changer doesn't get out of step or out of time. Also, you want to check all the accessible pins, keys for fatigue. Mainly this is outside the cabinet on the tap changer that you're looking at. We're talking about the motor drive. Talking about cleaning and inspecting the wiring and the contactors, auxiliary switches. These are all in your motor drive cabinet is where these components are going to be located. But it's a good time to check them all and make sure that you don't have any oxidation going on your contacts, no loose wiring or frayed wiring going on since it's been operating. Obviously, on the side of a transformer, it's going to receive some vibration, so things do have a tendency to loosen up or move over time. Maintenance specific to the what we call the arc and oil LTCs compartment. Basically, you've got to thoroughly clean them. You're going to have carbon inside these compartments because of the arcing going on. So when you drain the oil, you're going to see it looks like a lot of black carbon's been in there. You need to clean all those thoroughly, clean the contacts thoroughly, clean your insulation boards thoroughly so you don't have any tracking, anything of that nature. And then again, the attention to the mechanical wear and arcing of the contacts. The main purpose of doing an LTC inspection is to look at your contacts that are basically making the connections for you from your tap changer. Most tap changers are 33 position or 17 position. So depending on the method you're using or the type of unit you have, it could be seeing a lot of operations in a year's time. And when I say a lot, 10, 20,000 operations, and we see as many as 10 to 20 on some transformers. So obviously you're going to see a significant difference between the two. But the main thing is to look at the contacts and you can see the contact wear. And there's dimensions you need to be checking on those for tolerance levels to know whether you need to replace them or if they're acceptable to go on. You want to check the resistance in an LTC, the ones that are what we call reactance type tap changers. Basically, you're just verifying the resistance values, which is inside typically on these type transformers. Also, if you do an in-tank LTC, this is just a picture here. This is what we call the diverter switch. It drops down inside this tank here. And then below that is what we call the selector switch. But the diverter compartment is a separate compartment all of its own inside the transformer tank. That's where all the switching and arcing goes on inside this unit. So there's another compartment where all the leads, the selectors of the transformer, connect into on this in-tank type tap changer, but it shares the oil with the transformer. This, though, is a separate compartment all of its own called a diverter switch compartment. But you're checking the contacts. The same scenario goes on as with any other type tap changer. You're looking at the linkages, the gears, the contacts. Talk a little bit about capabilities. We have parts of all these contacts, linkages. We have a group in our organization. Some of them are in the back of the room with me today that sell these parts and components, sell the service to perform all this work. You need a good qualified technician to be performing this work. We find out a lot of times people will try and do the work and they create more problems, which costs more money in the long run than just hiring a technician that understands the various different tap changers. And I'll show you a list of the different tap changers, and I think it'll give you an understanding of why we say have a qualified technician. We also do LTC upgrades and retrofits on specific models. We'll talk about that. We replace various different models. I've got a slide showing the different ones that we've replaced throughout the recent years. Basically, it's a customized approach, though, to each situation, depending on whether you're an industrial user or a utility, depending on the current value or voltage value of the LTC, determines the model that we would use or the upgrade or retrofit that we would put on it. Some cases you can upgrade the tap changer to a newer model or a faster model. We've done some retrofits where we've gone from a 2-second tap change to a 1.5-second tap change. Part of that was a nuclear requirement. So we ended up developing a whole new PA, whole new tap changer on what was a de-energized tap changer type transformer. So there's different ways to put all these upgrades and retrofits in application. And that's what I mean, everyone's custom. If the units are similar, sometimes you can use the same LTC, but you always have to have a review of the design in some form. We talked a little bit about online oil filtration. We also have those filtration units that we can install on existing units and also on the new units. But it's something new that, well, not really something new. It's been out there for a few years, but it's something that's becoming more commonplace to put on the LTCs. The experience level, we have done dozens of LTC retrofits. We know a lot of our competitors do a lot of retrofits as well, but we make sure that we have the design information of the unit that we're going to perform the work on. That's one of the key things we look at, because part of it, as I was saying, you need to understand the transformer design so you don't misapply the LTC to the transformer and create more issues or more problems down the road, rather than just replacing an older LTC. Uprating potential, talked about the knowledge, but at that time you can look at uprating the transformer in some cases. The limiting factor may be the LTC is what we found. In some situations where we put a larger LTC on, you can get more capacity out of the unit itself because the current carrying limitations of the previous LTC were lower than what the rest of the unit may be able to. So you can also look at uprating at that time. Many of the tap changers will say were and are good designs. There's a lot of LTCs that have been out there for many, many years, but it takes a specialist, as I was talking about, to rebuild these tap changers. The guys that we've utilized have had years of experience in the factory, also in the field experience, and all across the different manufacturers, utilities, industrials, things of that nature that use them in all different manners. Also, OEM or better quality parts. When you get into the LTCs, you've got to have a parts list. A lot of times we know what we need before we get into the LTC just based on the number of operations that the units had, whether it's contacts, whether it's some springs, things of that nature that we can have on hand up front. Sometimes if you don't know the number of operations or it's quit working in some cases, or you don't have a maintenance list of when you last performed maintenance, sometimes you have to do the inspection and then come back with all those parts later on to do a build-up or a rebuild of the LTC itself. It's just depending on the situation and what information you basically have up front that can create this parts list. But as part of that is in the OEM, we have a lot of suppliers that supply us parts, but we have our specs that we give them, the drawings that we give them, and there's other companies out there trying to duplicate parts. for you, and we'd advise you not to do that because we've gone back a lot of times, and a lot of the issues we see with LTCs are subpar parts that somebody has just fabricated in a shop for you or for the customer in that case, and turned around and it was just not working in that application because they didn't meet tolerance or the material spec wasn't what it needed to be. The products we support are the ABB, Rheinhausen, GE, Westinghouse, Allis-Chalmers, Federal Pacific, and then if you have a problem unit, you can always look at an LTC retrofit. A lot of cases, a retrofit solves the problem of an older existing LTC that may be beyond its years of useful life. Talked about procuring new or better parts, and we'll supply the parts, or we can supply the parts and the LTC technician, depending on what's needed. We can handle the oil, or we can have the customer handle the oil. We're pretty flexible in that regard. We're just trying to make sure that if we get an opportunity for an LTC, or if we have an LTC maintenance that we're involved in it, that we're understanding what the customer's needs are at that point, so we can make sure they're benefiting as well as we're benefiting from the LTC maintenance, and that we have everything covered. That's the main concern, that if we're sharing the workload, we make sure that we have a schedule in place, that we're talking the same thing throughout, because timing is kind of critical in most cases. An LTC inspection will take about 1 day. If you're changing a lot of parts, it may run into 2 days. But if you're doing a retrofit, it can be as long as 2 weeks. So depending on what you're getting into, it can be a very short period of time. But if we're talking 1 or 2 days, everything has to be coordinated, everything has to be there and ready to go. Again, we talked about an experienced LTC specialist. When you perform an LTC upgrade, it's always a customized recommendation. Advanced planning, I just talked about that. Uprating potential. We talked about the detailed knowledge of a transformer design. Allows us to do that ability at that point. But that's something separate than just doing a retrofit. We can look at the transformer and do a retrofit, but if we're asked to do an uprate, that's another step in the process that we have to run through our engineering group, which takes time as well to accomplish before you can do the LTC quote. So sometimes that can delay the process to determine whether it is even a potential for an uprate. Troubleshooting, inspection, we talked about all these items, the timing, the rebuild, the parts identification, the turnkey service, and the retrofits. Basically, these are all the LTCs that we have the ability to provide OEM parts on. You can see the list is quite extensive. Some companies built many LTCs for various reasons. Some of the LTCs are very similar in make or model, maybe a different version came out later that's a higher current capacity, so they called it a different model, or a higher voltage capacity, so it's a different model name, but the component parts are very similar, I'll say. LTC condition evaluation, some of the new developments we have going on. We have the accelerometers, we have a TAP 4 device, current sensing device. All these component parts and monitoring devices tell us more information about the LTC than we had previously. What it allows us to do is somewhat determine the maintenance cycles on an LTC. Some of the new devices, we'll talk about the VR LTC that we've got out on the showroom floor. That's a new unit. It's utilizing a measuring system to control everything instead of the cams and switches that most of your LTCs have in them. This is just part of it. These can be installed on existing units. An alternate to an LTC replacement is some new reversing switch design improvements. We've gone in and we've seen some of the designs on a what we call Allis-Chalmers TLH21 and a McGraw. We've gone in and looked at the reversing switches, and we know that every time we've gone in, you'll see some pictures of what we're finding inside these units. So we've developed some reversing switch contacts. We've redesigned them. We've gotten some patents on some new designs of the older models to basically work on those units, take those component parts out, put the new component parts in. A lot of it is tap changers. Basically, the tap changers that we're talking about, they were utilized back in the 60s, 70s, 80s. They were over-designed, basically. They were only operating at 40 to 60% of their capacity. But today, with the extra loading on the units, they're running 100%, or some of them are even running over, and it's creating these problems that we're seeing on these reversing switches. So part of it is we designed something that was not there 40, 50, 60 years ago. Also, if utilities are removing or replacing a tap changer, increasing numbers per year seems to be another issue that's going on. Basically, the tap changer is changing more frequently, which obviously creates shorter maintenance cycles because you go by the operations typically of the unit. The cost to do an LTC retrofit is around $175,000 to $250,000. Depends on the model of LTC that you have and the model that you're replacing it with. So there's a lot that goes in with that. That's why you see that broad band of cost, I would say, for an LTC retrofit. Basically, most of the transformers that we do the retrofits on is 35 to 40 years old. We've done some as soon as 15 years just because we're uprating the unit for that purpose. But in most cases, you find it's older units with the older LTCs. Talked about the Alice Chalmers. This is the original design. You can see discoloration here. This is what I was referring to when I was talking about the coking. This is what it looks like inside the unit. Basically, it's built up. When that leaves position and comes back, it's hard for that to make a clean connection. So what we've done, we've gone in and this is the original design. You can see you have flat blades here. You can see how it just rides on the surface, and when that coking builds up, it basically starts separating those contact points. Then you get more arcing, then you get more coking is the phenomenon that happens. We've created this new switch, which basically has 3 fingers on top, 3 fingers on bottom, and then they ride on this rail when they start reversing. They go from here to here. And what that allows it to do is with the 6 fingers, it cleans the contact surface. So it's not building up that film as frequently as it would with the one flat, solid piece of copper. So it's actually doing what we call a wiping of the contact when it goes on and a wiping when it leaves. So you reduce the contact wear a little bit. You also reduce the coking effect that goes on in these LTCs. This just shows you a breakdown of the different component parts. Talked a little bit about a silver inlay in the contact parts. What that does is that keeps the temperature down on the contact surface. So what that allows us is once you get the temperature down, then you have a better scenario to not create the carbon oxide that we were talking about when we were talking about the oil sampling and stuff. So it's just another advanced method that we have today that was not necessarily going on. Talked about the selector switch, the moving contact, finger assembly, and the stationary contact is a tungsten type content as well. It prevents the heating, coking, because we have the 6 contact points going on and off. They're moving contacts as well. They're spring-loaded inside there, so they have tension on them themselves. Even though they're current carrying capacities, that's where we get our tension. They ride on the rails. We have the silver inlay that I pointed out. Success factors, we have a reduced force on the contact, which means you have less contact wear. And then we've thermally tested it, mechanically proven them with over 1 million operations on a tap changer to prove that these contacts are doing exactly as designed, and then we can get many years of service out of them. This is a McGraw-Edison, what we call 550B. Basically the same type setup. You have the flat blades here. You had the 2 current carrying capacities, and we've changed that to where now you have the rail that it slides on, and then the 6 contact points, the 3 on top, 3 on bottom. Very similar design. We've also changed out the insulating board. We found out that the insulating board was an issue as well inside this particular model. That's what it looks like inside the unit. There's a 3-phase unit putting it in service. And here's what some of them look like when we get to site and look at the LTC. You can see that you got a lot of coking going on. There's basically tracking almost going on from here to here continuously. So basically this is becoming a current carrying capacity where we don't want that going on. And that's how you end up with failures inside LTCs. Talk about retrofits for a moment. Replacement may be the best option when it's economically going to solve the problems that are inherent to some of the LTCs. It may be you're uprating the transformer, or you may have an LTC that is just, in some cases, better taken off because of the parts pieces inside it. You have to replace the whole LTC. The parts list becomes almost as expensive as a retrofit, or sometimes even more than the retrofit itself. And you're better off going with today's technology. because it's reached the end of its useful life, or reliability in some cases. A lot of tap changers maybe have hit their maximum number of operations. Some of them are 500,000, so that's what we call the end of their useful life, so you don't really have an option but to perform a retrofit. Basically, all the mechanical parts are designed depending on the application. We talked about that. We use a retrofit engineer, so he understands both the transformer and the LTC. And I think that's a critical point. We know there's some replacements going on where the transformer design is not being looked at. They're just looking at one for one, trying to match up an LTC to what the existing LTC is. And you can run into a lot of issues there. It's just like changing something out on your car. If you don't know exactly what you're replacing it with, you can run into a lot of problems. Same thing and even more extreme on an LTC, because you can have a failure depending on your voltage levels and your current levels in your LTC. You have to make some choices whether you're going to use vacuum or resistive. The modern designs have higher reliability. You've got more spare parts. And in most cases, the parts are actually going to be cheaper than trying to duplicate some of the older parts of the older models. But substantial engineering and drafting is involved. I was talking a little bit about that up front, but it takes a lot of time to do an LTC retrofit. It takes about 6 weeks to get it through engineering and drafting before we can have a formal design and drawings for review for a customer to even start the process of acceptance of the drawings, and then we start the ordering process at that point. So some tap changers we can get in about three months, some are about 6 months. So it depends on the tap changer, depends on the type of retrofit that we're going to be doing. You do get the improved reliability, basically because of the tap changer being brand new. Our new VR LTC will talk about the number of operations, how long the maintenance cycles are, but they're about 10 times longer than some of these older models that you have out there. So the reliability is built in. You avoid the cost on a retrofit of shipping the unit back to the factory just to change the LTC. If the LTC is the only problem you have, in most cases we can do a retrofit. You saw the cost. Some of the shipping costs alone will be that transportation cost one way to a factory. So you have a significant savings there. You have the reduced downtime. If you're not taking the unit off the pad, moving it to a customer repair location, you have that time frame that's much, much shorter on site. Like I say, typically a retrofit in most cases will run anywhere from 2 to 4 weeks. 2 for a normal tap changer where we can unbolt one, weld another one on, bolt it on. If we have to do a lot of modifications, adding PAs, or just changing the whole design of the board, have the leads route through, it can get up to 4 weeks in time. This is some of the models that we've done some retrofits on. You can see it's a whole variety of different type tap changers being applied with a whole different variety of other type tap changers. You have the Westinghouse, the Federal Pacific, you have the Ferranti Packard, the GE, basically taking off the older models and putting on something new in today's market. Talk about a retrofit we did on a GE to RMV2. It's on a 21 MVA GE single-phase transformer. This was an arc furnace transformer, so it saw a lot of tap changes quite frequently, and the tap changer just basically hit the end of its useful life. So it was better to do the retrofit. Ended up with reduced maintenance. This is a picture of what it looked like previously, and then when it looked like when we were done. In this particular case, we had to put a throat on the LTC. The new LTC coming in was actually larger. I say larger, it was wider than the old LTC, so we had to build a throat to bring the transformer tank out wider. Had to push the window footprint of the transformer out a little bit, but we're able to do those things if we have the information. Talk about an LTC reactor retrofit to replace the de-energized tap changer. In some cases, customers need to switch under what we call a de-energized, which is basically 69 kV and lower for us. It's called a delta Y switch, but you can change your whole transformer voltage on your high side with this type switch. It's a very similar type retrofit that goes on as a normal, what we call LTC retrofit. Basically, we perform over 200 service maintenance on LTCs a year, whether that's retrofits, whether that's inspections, whether it's actually maintenance on LTCs. But you can see the list, basically some service projects that we've done recently. We do it for industrials, we do it for utilities. About any LTC out there, we have someone that can service the LTC, so it just depends on the end user, where they're located, depends on how long it takes to get someone there. These guys are normally booked quite frequently months ahead of schedule, so if you have LTC maintenance you're looking at, it's something you need to plan ahead on. Part of our history, we've designed and installed LTCs on different makes of transformers, demonstrating the ability to do the custom engineering and service work proven to get predictable results. Basically, we have a lot of companies, even within ABB, that produce a lot of different products, small power, medium power, large power. LTC goes on about every one of them. So we'll touch a lot of different models, a lot of different types. There's core form, shell form, that all have LTCs on them as well. Been doing the retrofits since the 1980s, so we have a lot of experience when it comes to the retrofits. A lot of our engineers doing the retrofits were the engineers that designed the transformer previously that are still with us. So those guys have a good knowledge of what they're up against, so it makes it somewhat easy, I'll say, for us to review the designs and come up with a good fix. We also have field technicians that have been factory trained and qualified. The guys that we send out are qualified technicians. It's not someone we just pick up and send out. These guys go through all types of training every year. We have annual week-long training. LTCs, we've sent the guys overseas to get training on some of the different models coming in that are the in-tank that we don't necessarily build here in the States. So these guys go through a lot of training to get the experience that they have today. Talk about the VR-LTC. This is our new load tap changer that's coming out. Basically, we've got it out there in service now. It's an on-tank vacuum reactance load tap changer. Right now we have the 25 kV 1500 amp that's out there. It's been out there for a while. It's got about 21,000 operations and it's just hum along just fine. There's production on that one. It starts in June 1st this year. Then we have the next model is a 25 kV 2000 amp. It comes out the first quarter of 2013, and then the 2500 amp comes out in the third quarter of 2013. But it's basically fully compatible or equivalent with other LTCs or other manufacturers are using them as well, not just ABB. And then they're tested and conforms to IEEE and the IEC standards, and they're manufactured in our Alamo plant. Has a plus-minus coarse or fine or linear switching. Basically, it's a 33 position. We have it where it'll operate in 2 seconds, which is the time it takes to make the tap change, or special order, we can get it in 1 second, which is a special condition. Proven vacuum interrupter technology, we've had that for years. They've implemented that in the tap changer. Also a fail-safe lockout mode, which is critical as well. Intelligent servo motors, or the drive motors that are operating it. And then we have what we call a TLMS, which is a monitoring and decision-making computer, basically, is what it is on board, that you can set it up to monitor various different modes of the LTC. This is what we're talking about when we have a plus-minus tap changer. Basically, you have your leads coming out from your transformer winding, what we call the regulating winding. Your reversing switch basically just gives you your additional taps when it taps up or taps back down. It gives you 2 plus and minus is what it ends up doing. It adds turns in, takes turns out. Tap changer then just steps from one point, and then this one would step over. So it'll just move along step to step. Up here is where the arcing goes on when your vacuum interrupter. What that does is that interrupter, as soon as that starts to go on position, it switches it out here in the bypass. The bypass opens, the vacuum takes the current going into the next position. So all that arcing and everything is happening in that vacuum compartment, which reduces your contact wear and tear. Mechanical endurance, 500,000 operations is required by the standards, but we actually tested it 2 million operations was tested. And then we have the contact life test was greater than 1 million on the full load. Inspection intervals, we have a 500,000 operations, which is just an inspection interval. Then we have a maintenance interval, which is a 1 million after 1 million operations, which will take quite a few times. I think I've got a slide here to show the time on that. Virtually, it's maintenance free because it's a servo motor. There's no electrical, mechanical devices that we use for the timing, unlike the cam switches and everything that are used. on a lot of tap changers. The TLMS does all that for us. This just shows you the duty cycle, the number of operations per day, per year, just to give you kind of a chart of how long it would take before you'd actually need to do an inspection on this LTC. You can see it can be as short as 15 years, which 15 years is not really that short, but up to 50 years, depending on the number of operations or application you have. In the industrials, you'd go through this pretty quick. On the utilities, you'd probably get up into the 15, 20-year range sometimes. Like I say, strictly depends on where the unit's operating. The intelligent motor drive, basically it's a servo motor with a position feedback. Then we have a multi-turn absolute encoder, basically eliminating all the cam switches as well. The TLMS monitoring system, it records, it analyzes, it decides, it makes all the decisions for this LTC when it's in operation. It gives you the phase angle when it's changing positions, so you can do maintenance checks with it in the service, which allows you to check your time and things of that nature. Thanks everybody for attending.